Let's analyze this hyperbola in standard form. Okay, so the first thing I'm going to do here is actually write the standard form right underneath it. And so that way we could recognize what's going on. And remember, if the y squared is actually written first, this is actually a hyperbola that opens up and down and then with vertices in the y direction. Let's identify our center. Remember, our center is HK. And in this case, H is 1. And we have K to be -6. So there's our center. Next thing we want to find are our vertices. And because it's opening up and down, well, we can identify our vertices by going up and down 2 units from the center. So that means our vertices must be what? So if you went up 2 units, we'll go to 1, -4. And if we go down 2 units, we also get vertex C, another vertex, you could say, 1, -8. So there's our vertices right there. Okay. Next thing we want to find are the foci. And in order to find the foci, we need to know that for a hyperbola, we have that c squared is equal to what? A squared plus b squared. Now we do know that a squared plus b squared is 29. Let's solve for c, absolute value of c. Oh, remember that c is greater than 0, okay? But the absolute value of c now is equal to the square root of 29. And of course, to solve an absolute value equation, we know that c is equal to what? Plus or minus the square root of 29. Now we know that c is greater than 0. That means c must be positive square root of 29. Now remember what we're trying to find here. We're trying to find the foci. And so the foci is located just inside those vertices, somewhere around there. Okay, so that means we're going in the up and down direction again from the center. Okay, so we could actually find our foci now. So from the center, we know 1, and then we can go, let's say we go up first, -6 plus root 29. And then the other focus point is 1, comma, -6 minus root 29. And so we have the foci. The only thing left to find are the asymptotes. Okay, so let's try to zoom in to this a little bit more. And what I mean by that is, let's try to draw the little rectangular box from our center. So usually I draw the center with an asterisk. Now, our little rectangular box says it has to be what? Up 2 and then right 5. So we can go up 2 and right 5. Okay, and of course we can go down 2 as well and right 5. So we really get like this rectangular box as such. Now I don't need this part, so let me erase this part again. There we go. Now what do your asymptotes look like? Your asymptotes go from corner to corner and through the center. So we want to find the equation of this line. It's not too difficult actually, because we already stated the slope. Let me clean this up a little bit. There we go. And so we just got to remember the slope here. This slope is what? So for this line, the slope is positive and is actually up to right 5. Now for this line, it's negative. So it's actually down 2 and then right 5. Okay, so we're ready to find our asymptote. So let's find the first one. So the first one is y minus y1 is equal to m. Let's call this m1. Let's call this one m2. m1 x minus x1. Now what am I going to use for x1 and y1? Well, why don't we just use the center? So y plus 6 is now equal to m1, which is 2/5, and then x minus 1. Typically, we would like to write this in y equals mx plus b form, so let's do that. And we're going to subtract what? 30/5. So we have one asymptote to look like this. Y equals 2/5 x minus 32/5. So there's one asymptote. And why don't we get the other one? So the other asymptote would be what? Let's draw a little line down here. It would be y minus, once again, y1 equals what? m2. But what's m2? A negative 2/5. And then we once again have x minus x1. Once again, x1, y1 here is just the center, so it's really y plus 6 is equal to negative 2/5 x. Well, that's a weird looking 5. Let's fix that. Then we have minus a 1. And let's see what we get here. Y is equal to negative 2/5 x plus 2/5, but then minus 30/5. So plus 2/5 minus 30/5 is actually what? Negative 28/5. And there's your second asymptote. Why don't we go ahead and box our answers? So there's an asymptote. Here's an asymptote. Here are the foci. Here are the vertices. And here's the center as well. So we're able to analyze and identify everything on this hyperbola.